All right, so the stuff we're going to work on today is dealing with equations, tables, and graphs. So we're trying to put it all together. So let's look at some situations. So the first example is going to be making a table and writing an equation. So we're not dealing with a graph yet. So let's say the situation is you are saving $3 each week. You might be like, man, that's not much. But it's something. Something you're saving. So that's good. It's better than nothing. Make a table and write an equation to represent your total savings after a given number of weeks. Okay, so let's start right in. Just go ahead and make a table. So in our T-chart table, we're going to have the number of weeks. So we're initially starting at where we are right now with our total savings. At 0. Okay? We have a total savings of 0 so far because we haven't started yet. After 1 week, we'll have saved $3. Woohoo! At the end of 2 weeks, we'll have saved not 3, but $6 because we'll have had, if you think about it, this is you thinking about it, you have 3 from the first week and then another 3, right? Third week, we're going to have saved $9 because we'll, thinking about it, have saved 3 from the first, 3 from the second, and 3 from the third. So now I've made a table. I could keep going and going, but at this point I see an equation that represents this situation. So let's say I don't go to 4 weeks, I go to W. So I'm going to extend my table over here. So I say, let's go to the number W weeks. That could be any number of weeks, and I'm just giving it a variable name, W. So how much will I have made? Well, here, after 1 week, I had one $3 bill. Not $3 bill, but $3. After 2 weeks, I didn't just have one $3 saved, I had two $3 saved. And at 3 weeks, I had three $3 saved. So at the end of W weeks, I can see the pattern. I'm not just going to have W dollars, I'm going to have 3 times W dollars. So there is my equation, 3W, that algebraic expression, if I equal it to something. So let's say 3W, so I'm going to erase some stuff so I can write on here. 3W equals our total, so I'm going to say total savings equals 3 times W. Or I don't even need the dot there. And it could just be 3W. And this models my savings after a given number of weeks. Cha-ching. Okay, let's try something else. Let's look at this one. Now we're going to graph, and they call them linear equations. So we're going to graph some equations that turn out to be linear, and you might be like, well, what the heck is linear? Well, linear is an equation that when you graph it, if all the solutions lie on a line, and that's it. If when we graph it and we connect the points, it forms a line, a straight line. So this one's supposed to be a linear equation because it says so. It says graph the linear equation. And there it is. So what is it about? Jared keeps track of how much dry food is in his cat's feeder. Y represents the cups of food left, and X represents the number of days since he filled the 12-cup feeder. Okay, So I'd say for you, step one is going to be making a table. So a table of values where I have X representing the number of days since he filled the 12-cup feeder. And then Y representing the cups of food left. Cups of food left over. So if we go to 0 right now, how many cups of food are supposed to be in there? Well, it does say it's a 12-cup feeder, but what we're going to need to do is use this expression -1/2 x plus 12 and plug in what we're saying x is, which is 0. So now if I plug in 0, I would multiply first and then add 12. So when I multiply, I get 0, add 12, and I'm at 12. So at 0 days, I'm at 12. That's where he initially starts. Starts out at 12. Now is it going to go up from there? No. It's going to go down because the cat's going to eat it. So we could go to 1, but I'm going to be smart with this and pick something that goes into a half nicely, like 2. And I could even step it up into another multiple that would go into a half, which would be 4. But let's go ahead and plug in 2 days later for x. And when I do that, -1/2 times 2, that's going to be a negative number. Half of 2 is 1, so -1 plus 12, and I'm at 11. So it went down, so it makes sense. Now if I go to 4, can you predict if this was 12, that was 11, what do you think 4 is going to be? Let's see, I'm thinking it's 10, but let's see if it's right. -1/2 times 4 plus 12. And -1/2 times 4 is going to be a negative number. Half of 4 is 2 plus 12, and we're at 10. So I was right. Now, I could skip ahead and pick something much bigger than that, like 16. So let's say I pick 16. So now from there, I have -1/2 times 16 plus 12. -1/2 times 16 is negative. Half of 16 is 8 plus 12. And I'm at 4. So the food is almost gone now here. You could probably predict what number, how many days, where there's going to be no food left. But it doesn't say we need to do that. So let's go ahead and graph the ordered pairs. And it's supposed to be linear. So I'm going to go ahead and make a Cartesian plane. And really all I need is the first quadrant. So in the Cartesian plane, all I need is this, because that's the only one that makes sense. We have positive x values and positive y values. So I'm going to go ahead and draw out cha-ching. And this is going to be x, and x represents the days that have passed. And then y, the y-axis represents the cups of food. And now we need to figure out what to go by. So the days passed the x, well I plugged in all the way up to 16. So I could go by 2s, since that's pretty much, and if I'm going by 2s, I need to make equal increments. So if I go from here to here, I need to make it about there to there again, which wasn't great. And it does keep going, but I will stop there. And now I need to go and make increments for the y. And it looks like the y, I need to at least get up to 12. So I'm going to do the same thing and go by 2s and make them equal sizes. Now it would be much better if I was working on graph paper, okay? Because this isn't completely accurate. So my first ordered pair was 0, 12. So I'm going to go ahead and plot 0, 12. So 0 on the x, 12 on the y. So I start up here. And then I'm going to go to the next ordered pair, which was 2, 11. 2, 11. It's about right there. And then I had another ordered pair of 4, 10. 4, 10. And then I had another ordered pair, my last one, of 16, 4. Which doesn't mean that's the last one, but it's the last one I kind of computed out. So they should look like they lie on the same line, because this is supposed to be linear. So if I make a line that goes through them, so we can tell at some point past 16 days, and we could probably figure that out, not probably, we could, of how many days it's going to be when there's no food left. So perfect, we have our graph, and we're done.